Welcome, my fabulous chemistry students, to notes number 2, collision theory and the 6 factors. Collision theory, colliding, okay? We need to identify 2 factors of the collision theory and the 6 factors that are going to affect the rate of reaction. So this is how I manipulate this collision theory here. Okay? What conditions must exist for a chemical reaction to occur? That is the collision theory. And it defines the parameters for all the reactions. Okay? Changing the nature of reactants, concentration, pressure for gases only, temperature, surface area, catalyst. Those are the way I can manipulate my 6 factors to make the reaction go faster or slower. A little bit slower, Mr. Milks, a little bit slower. Collision theory. In order for the reaction to occur, my reactant particles have to collide or come in contact with each other. If they never touch, they're never going to react. Okay? So first, they need to come in contact, and then they have to have the right amount of energy. So if they come in real slow, they might not react. Okay, they got to have enough. And then they need to have the proper alignment or direction. So let me make a little analogy with my hands. If they're supposed to fit in good like this, and that's what's going to make them react, and they come in like this, not going to happen. So they have to be facing the right direction so that their activation sites, remember that from living environment with our enzymes, it's got to hit in the right way, or the reaction's not going to happen. Okay? So only when particles collide with these 2 conditions do we have what's called an effective collision, or the reaction will happen. Okay, so now that I have a reaction happening, how do I make it go faster or slower? So sometimes I want to speed certain things up. There are some slow reactions. There are some fast reactions. And those slow ones sometimes I can make go faster. Nature of a reactant means, is it ionic or covalent? That's what the nature of reactant means. And ionic substances are going to react faster, and covalents are going to react slower, and this is why. Ionic have smaller or less bonds to break and less steps. Okay, so NaCl, AgNO3, these are 2 ionics. I break their bonds, and they do their double replacement reaction, which we're good at. Okay, but it was just 1 bond in each, and then the ion completely dissociates. But in a covalent, I have a much larger molecule generally with more bonds, and we'll see here in the CH4, I have 4 hydrogens on either side of my carbon, so there's 4 of those bonds to break. In the O2, there's 1. And I form 2 CO bonds and 4 OH bonds. So if I just made a quick analogy, I don't have it written here, but here there's 1 bond, and here there's 1 bond, and so I'm creating 1 bond and 1 bond, so that totals 4. Here I have 8, 10, 11 total bonds, so 11 bonds is going to be much slower than the 4. Okay. Number 2, concentration. How much per volume of solution. And we just did the solution unit, so we know a little bit about concentration. If I increase the concentration, I will increase the rate of reaction. And the reason for that is the more particles in my given space means there's less space between them and basically a greater probability that I will have more collisions. And here's a little pictogram. So more space, here's my collisions. Not colliding, but yes, colliding. And now if I squish them all together, because there's more in the same space, the collisions are going to happen more. Okay? Pressure. Pressure is always one of those asterisk ones, if you will, because it's only for gases. Right? It will increase the reaction rate for gases only. If I increase the pressure, I will decrease the volume. We did that a few units ago in gas laws. This will decrease again the space, which effectively makes the higher probability to have more collisions. It's really a probability game. Temperature is probably the number 1 factor used because it affects 2 things. I will increase the rate of my reaction. I have greater speed. Therefore, I'm going to have more collisions. I mean, if I'm going slow, I get a collision, I get a collision. Now, if I get them going fast, there's going to be physically more collisions happening. And then I have greater average kinetic energy, so the collisions have that energy they need, so it's double-fold. I get more collisions with more energy, so temperature really is kind of the king of all the things I can do to speed up reactions. Surface area is the one we're going to have the most fun with in class. We're I am going to have the most fun anyways. If I increase the surface area, basically I have more pieces, which increases my rate. The rate increases because I have more places for that reaction to occur. Okay? So increasing the surface area exposes more reactant sites. Here's a very blurry pictogram. I don't know how well you can see that this one has one piece, and this is broken into 8 pieces, and then more and more. As I expose the big thing to smaller sides, more places for the reaction to happen. If I can happen in more reactions, the probability of my alignment being correct increases. If I get that probability to go up, my rate's going to go faster. We have one more to do. Catalyst. Special note, I do not want this to be your go-to answer. Let me explain. History has proven with students, they want to say catalyst is something that I can use as an effect as far as my 6 factors. Catalysts are very specific. They're very specific to specific reactions, and they don't work for everything. Not all reactions have a catalyst. So that's why I don't want it to be your go-to answer, because you can look like you don't know what you're talking about sometimes. So catalysts are the one that we would use only if we really know that it works. Temperature, that's the go-to one. Okay, temperature is number 1. It speeds up the rate of the reaction without changing the nature of the reactants or products. That is by definition. It also doesn't ever get used up, so it recycles itself. What it does is it provides a shortcut or an alternate pathway. If you're ever going to use it, this is the key term. You need to know that it provides an alternate pathway. We will delve into this, what this looks like graphically when we get into potential energy diagrams. It lowers the activation energy, so how much energy that reaction needs to go. And we're going to see that in a graph that looks a little bit like this, and it'll make more sense next notes. Okay? So now, we know what collision theory is. We know the 6 factors used. We have practice packets between pages 2 and 4 that you may have already done in class. There is a POGL. You do have a quiz prep on kinetics rates and a quiz on Castle Learning that you have to do now. So now you've done 2 notes. Now you have a whole bunch of things to do. Best of luck. See you guys in class tomorrow.